Okay, so here we have our milli circuit, our milli sequential circuit. And so what we're gonna test first is if it's functioning correctly. So comparing this to the state diagram, if we were to go ahead and run this circuit, so first we have our state A right here. It's 0, 0. And then should be 0, 1, which is state B, right? Then it would be 1, 0, which is state C. Then it would be 1, 1, which is state D, giving us an output of 1 right here. Then it should revert back to state A, which it did, and still equaling an output of 1, or an output of high. And so to the right of this sequential circuit, I made a little diagram as to how the sequential circuit works. So at first we have our inputs right here. Then we have our next state logic, and this is data signals from these are data signals from external sources. And then next we have our state memory, which are our combinational circuits which decide the instructions or which instructions to send to the state memory. And then we have our feedback loop, but in this case, this side it would be a more sequential circuit, and this would be a milli sequential circuit right here. And then our output logic is our combinational circuits decide which signals to send externally, which gives us our outputs. Should be these right here. And then this circuit, you can tell that it's a milli circuit due to the fact that it's able to function with memory, with outputs of memory and current. It produces outputs that are from memory and current inputs, which was shown previously right now when I tested it, and it shows that one fewer state within the memory is working, which is why it's in state A right here, and it's still giving us an output of 1. And so more sequential circuits depend only on past inputs, while milli sequential circuits depend on memory and current inputs. So it could do both, and in this case, it's doing both. It's doing the memory, which is past inputs, and then current inputs that are being inserted or sent through the sequential circuit right here. And the thing that made this or building this circuit a lot easier than it would be are these tunnels right here, which act like wires in that it binds points together. So it's basically like if these were connected. Every tunnel that has the same name or label is connected, and it's giving the signal that is being sent to the first one. So this one go this one, and this one go to that one. So it's receiving all the same uh, inputs or signals that each one is. You can see this one is high, so that's high, and this one's high. So it's like kind of like like a portal, but it makes it a lot easier because you'll need to add a lot of wires and make it all messy with a bunch of wires. It also helps if you need to connect points or points that are far apart from each other. And tunnels allow you to transmit signals without the use of wires, like I said right now. So, and to use the tunnels, you just have to go to wiring right here, and you find it right below the probe option. But yeah, this basically the whole sequential millicircuit. And this diagram summarizes how the sequential circuit works. For this side, it would be the Moore, and this one would be the milli. And then, of course, the clock input right here, which allows it to give you a time diagram and give input signals by itself if you were to use the auto tick option in Logician.